Hey everyone, in today's video we're going to be talking about translations in geometry. Basically in how a translation or what a translation is and how it affects an image. So let's go ahead and let's get started by first looking at an example of how do they word it in geometry. What does it look like in a picture, and how do we sort of write the symbols? How do we notate a translation? So here we have the formal definition of a translation. A translation is a transformation that maps all the points the same distance and the same direction. So basically we're sort of shifting our image to another location, and each point needs to move the exact same distance in the exact same direction in order to keep the image the same. So it's kind of like we just copy it and we paste it somewhere else. Okay, so here we can see that we have the original image, or like they call in geometry, a lot of times this is referred to as the pre-image in black, triangle ABC. And they shifted this triangle down and to the left, and we have triangle A prime, B prime, C prime in the red. Now the key points is that each point has to move the exact same distance. So if I were to really look at these points, I would see that each of these points, normally we don't just draw a direct line and measure the line. Typically what we do is we count how many spaces to the left, right, and how many spaces upwards or downwards did each point move. And we try to copy that for each point. So for example, point A moved to the left 1, 2, 3, 4 spaces, and it moved downwards 6 spaces. And essentially all of these points have to map out exactly the same. Now, similar to how slope works and how when we count spaces in math, if we go to the left, that is a negative value. A negative value is not only in terms of telling us how much something is worth, a lot of times in math, but it's a way for us to tell the direction that something went. If we see the negative symbol, it usually means that we went to the left or that we went downwards. Okay, positive values usually mean we go to the right and we go upwards. So this would actually be referred to as -4 and -6 because I went to the left 4 spaces and down 6 spaces. B would follow that same exact movement and go to the left 4 spaces. And again, because I'm going to the left, it's -4, and I'm going down 6 spaces. And each of these points would map out exactly the same, going to the left -4, down 6 spaces. And that's typically how we translate something. Alright, now I'm not talking about translating like we do from English to Spanish or any other language. I'm talking about translating an image to another location. Okay, going from the pre-image to the prime image. Alright, now how do we note this? Well, the way we write this, the way we notate this, is we have a capital T. Okay, that stands for translating. And then in these sort of brackets, we write how far each one of them moves. So down here you can see the formal writing. And I'm going to rewrite it to kind of explain what that means. So the -4, that first number that we write here, means how much the x value needs to change for each point. So that -4 means that each point is going to move to the left 4. This -6 means it's also going to move down 6 spaces, which you saw earlier that's exactly what happened. Here what we have in the parentheses is what we're going to actually move. So we're moving the entire triangle ABC to the left 4 spaces, down 6 spaces. And as a result, we get triangle A prime, B prime, C prime. So this is how we sort of describe how we're going to translate something. Now what we're going to do is I'm going to show you right now a quick example of what it looks like to translate a different shape. Okay, and here what you'll see is you're going to see an original image, and it's kind of in the shape of an L. It's that black shape that we're looking at. That's the one we're starting with. That's our original. And here are 3 good examples of what a translation could look like. Here's how I translate something. Sometimes it might tell me to move something to the right. So I'm going to move the entire shape to the right. It might ask me to move the original shape upwards a few spaces. I'm going to move it upwards. It might ask me to move it down and to the left. Okay. And this is what a translation looks like. Alright, here we also have an example of what a translation doesn't look like, and that's there in the orange. That's the shape D. If you look, it doesn't matter how I move this, it'll never match up with that orange shape. Okay, and that's because it looks like to me that they've also rotated this and reflected it, which is not what translations are about. Translations are really just focusing on moving it to the right, to the left, up or down. Also, we're not changing the size of the shape. Okay, that also has to stay the same. So these are important things to keep in mind of when you're changing or when you're translating a certain shape. Now what we're going to do is we're going to go ahead and we're going to take a look at an example of a problem where we need to sort of write the rule for how they translated a shape. Translating shapes is not that hard. We simply just follow the rules that they give us. So if they told me to move this down, so for example, what we're going to do two things here. First, we're going to write a rule for this translation, and then we're going to try to translate it ourselves to another location. Okay, so first let's see, can we move A, B, C, D? They moved it to A prime, B prime, C prime, D prime. Can we tell what they did for each point? Can I write the rule for this? Well, in order to do that, I really only have to take one point and count how many spaces they moved it. So for example, I'm going to take point D. Doesn't matter which point you choose, but point D here, I can see they moved it downward 3 spaces. So remember the direction of downward, that's a negative direction. So they went down 3, so that's a -3. And they went to the right 1, 2, 3, 4, 5, 6, 7 spaces. Going to the right is a positive direction, so we keep that 7 positive. So really the way that I would write this translation, I'd say that triangle ABCD, okay, I could just say it was translated, that's what the T stands for. The rule that they followed was that they went to the right 7 spaces. So we write that direction first, and then we write whether or not they went up or down next. And then they went down 3 spaces. And that's sort of the rule that they have followed. So I can check every other point, and I'd also see this. I could test, let's go ahead and let's just check A real quick. It goes down 3 spaces, and it should go to the right 7. And if I count that out, you would find that it is 7. Okay, so that's the rule that each of these points follow. Now what we want to do is let's go ahead and let's make up our own rule, and let's see if we can actually translate. So how do I actually translate something like this? Okay, so let's say I'm trying to follow the rule of I want to translate this. Let's go ahead and let's go up 1 space, and let's go to the right 5 spaces. Okay, so the first point I would do that, I'm going to go ahead and go in alphabetical order. Let's go up 1 for A, up 1, and to the right 5 spaces. 1, 2, 3, 4, 5. And this is where my new point A would be. So we're going to go ahead and make this new shape in purple. That's going to be my new sort of A. I'm going to call it double prime, so that we don't get confused with the original image. And let's go ahead and now let's do that with point D. We're going to go up 1, and we're going to go to the right 5. 1, 2, 3, 4, 5. That's going to be point D double prime. I know I said I was going to go alphabetical order, but sorry, just changed my mind. I'm going to go point C now, up 1 space, to the right 5 spaces. 1, 2, 3, 4, 5. That would be my new point C. Again, these will be double prime. And now I just need one more point, that's point B. I'm going to go up 1 and to the right 1, 2, 3, 4, 5 spaces. Okay, let me actually recolor code these so that you can also see what I did. So we went to the right 5, up 1, and this would be the location of B double prime. Now we can connect these points. And that's how we actually translate an image. Okay, and that's pretty much it when it comes to the graphing aspect of how to tell how was an image translated. So we can now determine how they moved one image to another spot. That's how we came up with this rule. That's how we got to the black image to the red image, and then how to write a new rule and actually move an image. So hopefully now you feel confident enough to be able to translate images on your own. Again, it's just about moving it from one spot really to another, either up, down, right, left, or a combination of any of those two really. What you're going to want to do next is check out this next video, in which instead of looking at graphs and visual images of what translations are, we're going to take a look at points and the rules of translations, okay, and see if we can apply them directly to points instead of an image. So if I'm giving like different points, can I apply these rules to those points and get a new point? Okay, so definitely check that out. If not, just thanks for watching this one, and I hope you continue to learn.